down to -64, up to 0, up to 125. So firstly,
relative minimum?
Careful. It's the end point. Keep that in mind. You can never say relative because it's at the end point, right?
Okay.
So from 0 down to -64, up to 0, up to 125. So what type of point is -2, 0?
Nothing.
Yes. What type of point is 0, -64?
It's a minimum, right?
Yes, it's an absolute and also relative min. Awesome. Now we are here. What type of point is 2, 0? There is no sign change.
Nothing.
Nothing. Finally, what type of point is 3, 125?
Absolute max.
Can it be relative?
No.
No, because it's at the end point of the interval. So this is how we study the max min of a function on a closed interval. We create a table with a closed interval. We determine the derivative. We find all critical numbers. We have to study the sign. This cannot be anything 2, 0 because the function is increasing, and then 0, and then increasing. In other words, the derivative is positive, then the derivative is 0, and then the derivative is positive. There is no sign change. If there is no sign change for the derivative, the function cannot have a max or a min. So it's coming from -64, goes up to 0, and goes up to 125. That was all we needed to do. We needed to identify these points. The points where the function has a critical number, and as well as the endpoints. Absolute and relative, because we can show the function exists on both sides. That's why it's also relative. Here we cannot show the function on both sides because we were given this interval. We cannot extend, but you can say, but the function exists to the left of -2. The function exists to the right of 3. I can't. I am given this piece. I have to stick with it. So that's why these two at the end points can never be relative. Awesome. Is this okay, or we want to choose another?
Good.
Should we look at a natural log? Should we look at a trig function? Natural log, for example, this x, the -2 natural log.
Let's do a trig one.
Okay.
62.
62. Let's take a look at the trig one. 62. Perfect. Let's do that. And also, I would like to look at, after that, at 63. And then we move on. So 62, you said f of theta equals 1 plus cosine square theta, and the interval is pi/4 to pi. So half of the first quadrant and the entire second quadrant. Fine. I get my table going. Theta this time from pi/4 to pi, and f prime of theta, and of course f of theta. Good. So this is always defined on pi/4. Its derivative, it's always going to be defined, so no critical numbers coming from f prime being undefined. But I'm going to write it anyway, so it's a refresher. Always, number 1, f prime of theta equals 0, and number 2, f prime of theta is undefined, none. Because when we find f prime, can anyone give us f prime of theta? So the function is 1 plus cosine squared. How How do we get f prime?
-2 cosine theta sine theta.
Yes, -2 cosine theta sine theta. So we bring down 2 times cosine times the inner function prime, which is negative sine. Awesome. So from this product, -2 sine theta cosine theta equals 0. I am allowed to divide both sides by -2, not by variable or functions. And then I have either sine theta equals 0 or cosine theta equals 0. So from the unit circle, sine is 0 here and here. At 0 and pi. We don't have 0 in the interval, but we do have pi. So at pi, this is one critical number. So x equals pi, critical number. Good. So let's see when cosine is 0. Cosine is 0 here and here. But we don't have this in the given interval, but we have this. So I have to punch in pi over 2 and put 0 here. At this point, I have to determine the function values at each of these 3 points. And I have to study the sign of the first derivative, left and right. Okay, so it's easy to determine because cosine pi over 2 is 0 and 1 plus 0 is 1. It's easy to determine this because cosine pi is -1. -1 squared is 1. 1 plus 1 is 2. And this one, cosine pi over 4, is the square root of 2 over 2. Let me write it here for you. So f of pi over 4 equals 1 plus the square root of 2 over 2, everything squared. That's easy as well. So this is 1 plus 2 over 4, or 1/2. So this is 3/4. 1 plus 1/2. 1 plus 1/2 is 3/2. Don't trust my numbers today. Okay, so we have here 3/2. Oh, I can write 1.5. Okay. So now I have to study the sign of the derivative to the left of pi over 2 and between pi over 2 and pi. So let's see. This is also easy. Let me copy it here. F prime of theta, -2 sine cosine, yes. -2 sine theta cosine theta. Anyone remembers what formula is this? What identity, what trig identity is this? Without the minus, of course. Minus sign. 2 sine theta cosine theta. Does anyone remember what this is? Anyone? Okay, sine 2 theta. If you don't remember this, we can use this, it doesn't matter. So at pi over 2, 2 times pi over 2, I need before that, sorry, that's clear. We already have the answer. So it's 0. So I need, maybe we should do that because I can plug in between pi over 4 and pi over 2, I will be plugging in pi over 3. So this is 45 and this is 60. And here it doesn't matter. I can choose anything like pi over 2 plus pi over 6. 3 pi over 6. Pi over 2 plus pi over 6. So this is 4 pi over 6 or 2 pi over 3. 2 pi over 3. Or just any angle. It doesn't matter. I can erase those and we just plug them in, but it's easier if we just use angles. But probably the answer is not going to be exact anyway. I'm going to share my screen. I just put it in. It's okay. It was easy with the other function, but maybe this is more difficult to see. But that's okay. So I'm going to put in minus sine 2x or 2 theta and close the parenthesis. Okay, so I want to plug in. I can plug in pi over 4. It's fine. It doesn't matter. Pi divided by 4. I want to make sure that I have radian mode. Because if I don't, then I'm in trouble. Okay, so for pi divided by 4, I get a negative number. I'm going to put the sign. And for 2 pi over 3, 2 pi divided by 3, I get a positive number. And now the moment of truth. This is when we catch our mistakes. Okay, from 1.5 to 1, the function is decreasing, and that's supported by the sign of the first derivative. From 1 to 2, the function is increasing. Yes, indeed, and it's supported by the sign of the first derivative. So now we need to identify what pi over 4, 1.5 represents, pi over 2, comma 1 represents, and pi, comma 2. And you can create this little thing. This is not the graph of the function. 1.5, 1, 2. 1.5, 1, 2. What type of point is pi over 4, comma 1.5? For this function, what is it?
Nothing.
Nothing, indeed. What type of point is pi over 2, comma 1?
Minimum?
Yes, absolute and relative minimum. Absolutely. Perfect. Awesome. What type of point is pi, comma 2 for this function?
It's nothing again. An absolute max.
Yes. So this is the height of 1.5. This is the height of 1. And this is the height of 2. It is the absolute maximum. Again, can it be a relative maximum?
No.
No, because it's at the end point of the interval. Awesome. So before we look at that one with the natural log, I just want us to clarify one more time. So a note. F increasing means f prime of x positive. Vice versa. F prime positive, the function must be increasing. So you can read that dynamically from left to right and from right to left. If f is decreasing, means that f prime of x is f increasing means f prime of x positive. F prime of x positive means f increasing. F decreasing means f prime of x
Negative.
negative. Awesome. If f prime of x is negative, it means f is decreasing. Awesome. Thank you. Okay, so I just wanted to make sure, and let's look at one more, and then I think we have enough, but unless you say no. So page 9, what was that function? Was x to negative 2, so 63. F of x equals x to negative 2 natural log x, and the interval is 1/2, comma 4. Awesome. Perfect. Good. I get my table going. It has to be exactly what I'm given. I have to have f prime, and I have to have f of x. Now, I cannot conclude anything here. I have to make sure that whatever both sources are checked. So f prime of x equals 0. Can anyone differentiate that for us? Anyone would like to help? Anyone would like to help with that?
So it's going to be the product rule
Yes,
of
yes.
So it's going to be the first term is negative 2x. Sorry, to the power of negative 3, and then
Perfect.
times ln of x plus x to the power of negative 2 times 1 over x.
Perfect. Awesome. Another ugly situation, I have to simplify this as much as possible. So I have 2 over x to the third natural log x plus 1 over x to the third. I will factor out negative 1 over x to the third, and then I have 2 natural log x minus 1. Negative 1 over x to the third times this is the negative 2x to the third natural log x, and negative 1 over x to the third times negative 1 is 1 over x to the third. Good. So now the first one will be f prime of x is 0. Well, this is a fraction of 2 natural log x minus 1 over x cubed. So when is this 0? When is this fraction 0? When the
Numerator is 0.
yes. So 2 natural log x minus 1 equals 0, or 2 natural log x equals 1, or natural log x equals 1/2. How do I convert this into something I can solve? This is equivalent to e to power 1/2 equals x. Have no idea what this means. So the square root of e is 1.65. I'm going to keep it because I need to know whether it's in here between 0.5 and 4, right? It is. So I can write it as the square root of e and 1.65, so I know what it is. And I get here 0. Now from the second source, f prime of x being undefined, when will this fraction be undefined? When x is when x is
0.
yes. But I don't have to worry about it because the interval starts at 1/2. So this one is not a critical number, not because it wouldn't be, it would be, but because the interval is 1/2 to 4. So the final step here, I have to study the sign. And of course, I shouldn't say the final, I have to find these values. I have to plug in 1/2 in the function and get this value for f of x, f of 1/2, f of the square root of e, and f of 4. So now I can do this without a calculator. So I'm going to put it in. I'm going to share my screen. And I'll put in the function. Clear everything. And we have x to power -2. And then multiplied by natural log x. And I need 3 values. I need 0.5. I need e to power 1/2. And I need 4. Just give me the numbers. So I see -2.8. I see 0.18. And at 4, I see 0.09. 0.09. Good. Now at this point, I go back and put in the derivative. And the derivative was -1 divided by x to the third close the parenthesis, open another one, 2 natural log x, close, plus, no, not plus, but minus, minus 1 and close. And I only want to plug in 1/2 here. So when x is 1/2, the derivative is positive. And I only want to plug in 4, the derivative is negative. I copied the signs. At this point, I want to make sure that these two rows work well. If they don't work well, I know, oops, I did something. If they work well, most probably I'm fine. Okay. So from negative 0.2, this is negative here. From negative 0.28 to 0.18, the function is increasing. Is that supported by the sign of the first derivative? Yes or no?